Hi everyone, welcome to my YouTube channel. You are watching ETA, the channel which prioritizes and simplify education. Today, I'm going to be teaching you guys mathematics, which is one of my favorite topics. So today, I'm going to teach you guys exponents and surds. Now, what are exponents? Exponents are expressed in this form. Exponents are expressed in this form, whereby this is a base and this is the exponent. This whole thing is called a power. All right, now this is the exponent. Now, what are surds? Surds are all product or numbers under the square roots. Let's say, for instance, if you solve an equation under the square root and everything that you have solved remains under the square root. So the whole thing, we call it a surd. This is a surd. This is a surd. So whenever there's a mathematical umbrella, or the square root, whenever you see a square root or a mathematical umbrella, that is a surd. So we're going to be dealing with surds and exponents in this segment. Now I have to define few terms. What are real numbers? So real numbers are in a form real numbers are all numbers which are rational and non-rational. Now, what are rational numbers? Rational numbers can be expressed in a form A over B, whereby B is not equal to 0. And what are, so the symbol for rational numbers, that's it. Irrational numbers, now irrational numbers, when you punch them on a calculator, you will get a series of infinite and unpredictable values. So typical irrational numbers that we can talk about is the square root of 5. We can talk about pi, for instance. And we also have non-real numbers. Now, what are non-real numbers? If you punch them on a calculator, you will get an error. E.g., these are the numbers that if you punch the square root of, you will get an error. And why do you get an error? Now, if we talk about functions, which we're going to discuss later on, if you get an error, that will mean that in your function, there are no solutions or roots, or there's no x-intercept. All right. Moving right along. Going to talk about factorization. What is factorization? It is the creation of it is taking an expression and breaking it down into factors or into products. Let's say, for instance, if I have 8x squared minus 4xy squared, this will be, if I take out the common factor will be 4x into 2x minus y squared. That's it. So this is a sum or a difference. You can call it. This is the difference between two terms, and this expression here has two factors. It's 4x multiplied by that expression. So I factorized by taking common factors. That's one method. The second method of factorization is by grouping. So let's say, for instance, if I have an expression 3x y minus 2x plus 3y minus 2. If I group the first two terms and take out the common factor, I will get x into 3y minus 2, then plus this expression here will be 3y minus 2. Now, we have a common factor again. So if we take out the common factor, which is 3y minus 2, we are left with x plus, if we take out that common factor, we are left with 1. So this is it. The third way of factorization is the difference between two squares. Two squares. First of all, there must be squares. What is a square? A square is any number to the power of 2. So let's say, for instance, that means the numbers that are separated by a minus should have a square root when we are solving the difference between two squares. They must have a square root. The square root of 9xy is 3y. Now, how do we factorize the difference between two squares? We get the square root of this expression, which is 3x. The first expression, if the first expression has a minus, the second expression will have a plus. Now, the square root of y squared is y. The second brackets, we copy the same thing, but we separate with a plus. Then number 4, we have the difference between two cubes. So now with the difference between two cubes, let me give you an example. Then I will explain how it works. So what happens is you have the smaller brackets and the bigger one. In the smaller brackets, you must get the cube root of the first expression, which is 2x. Because it is the difference, on the smaller brackets, we will have a plus. Always, if it's a minus, this one should be a plus if we're dealing with cubes. So the cube root of y will be y, all right? And then the bigger brackets now. Now, how do we find the bigger expression? You divide this expression. You say this expression divided by that one. It will give you 4x squared. Then on the last number of the expression, again, y to the power of 3 divided by y. It will give you y2. Then what do we put in the middle? Now, in the middle, you have to multiply these two. So if you multiply sorry, I made a mistake. This one should be a minus. If this is a minus, then this one should be a minus. Now here, if you get the product of these two, it will be 2xy. That's it. The opposite of the difference is the sum between two cubes. Now, let's say, for instance, again, we follow the same principle. The cube root will be, but we're going to put a plus instead. And then the first term of the bigger bracket, again, 8x to the power of 3 divided by that expression will give us 4x squared. Y to the power of 3 divided by y give us y squared. Now the middle term, because it is the sum, we will put a minus, and that is the standard rule when you're dealing with sum of cubes. You always put a minus. All right. What is the product between this expression and that one? 2x times y. So it's going to be 2xy plus. That's it. That's it. Now we are moving to the last one, the most important factorization that we're going to be dealing with. It is the trinomial expression, but we're going to deal with quadratic expressions. All right, we'll give you an example. If we have 9x squared plus 5x minus 4, how do we factorize this one? There's many ways of factorizing these types of expression. However, I'm not going to waste your time. I'm going to simplify everything so that even the person who does not know how to factorize will be able to factorize. I just use a formula to factorize, the formula of roots. So normally, the x roots are given by minus b plus or minus the square root of b squared minus 4ac over 2a. This is the value of a, this is the value of b, this is the value of c. All right, let's see what we're gonna get. So on this one, we're gonna get a minus 5 plus minus the square root of 5 squared minus 4 into 9 minus 4. So this is the value of A, this is the value of C. Over 2 into 9. Now this is equals to minus 5 plus minus the square root of 25 plus 144 over 18. Now, this is equal to minus 5 plus or minus the square root of 169 over 18. So x is equal to 5 plus or minus 13 over 18. This is x equals 5 plus 13. We're gonna get 18. 18 over 18, that is 1. Oh, sorry, no, my bad. That is, okay, we have two solutions because we have a plus or minus. So let's start by the negative one. Minus 5 minus 13. It is minus 18. Minus 18 divided by 18 minus 1. Then minus 5 plus 13. It will give us 8 over 18, which is equals to, if we simplify, it will be 4 over 9. Now, how do we get the factors? If you take minus 1 onto the other side, you will get x plus 1 equals 0. And then on this one, on this solution of 4 over 9, first of all, we will say, if I cross multiply, 9x equals 4. Now, if I take 4 to the other side, we'll have 9x minus 4 equals 0. So we have factors, which are x plus 1, 9x minus 4. You will never get it wrong. All right, that's the simplest way of factorization, using the formula. Now, I made a mistake. I said this will be the last way of factorization, but it turns out to not be the one. We also have factorization by completing the square. Completing the square. Now, how do we complete the square? Let me give an example. Let's say, for instance, you have that expression. And you want to complete the square. You want to write it in a form A to x minus p squared plus q. The reason why p is a minus there is because this is a solution. If I'm declaring that x equals p is a solution, it means if I take p to the other side, it will be x minus p equals 0, just as what I did here. That is why this is the standard form. This is the standard form. All right. Let's say, for instance, if I'm given that. So in order to complete the square, let us start by factorizing, taking out 3 as a common factor to make sure that everything is simple, plus 5. All right. The next step will be, if I want to complete the square, first of all, I know that in order to get this value, I have to multiply the expressions in the smaller brackets. Let's say if I put a square root of x, I get of x squared, I get x. But then I don't know the number that I have to pay with x in order to get that expression. But the only thing I know is that this is the square. All right. In order to get this value, I have to take that expression divided by, in brackets, divided by, in brackets, 2 times x. So it's going to be, let me do it on the side, 4x divided by 2x. So this is going to be 2. It's going to be plus 2. Plus 2. However, I need, however, if I add an expression, I have to subtract it right here. So what is it that I'm going to be subtracting? I'm going to be subtracting the numerical value that I get when I multiply, when I expand this expression. The numerical value that I'm going to get is 2 to the power of 2, which is 4. So now this is in brackets. Okay, so we're going to have 3 into x to the power, x plus 2 to the power of 2 plus 1. So we can also write it as 3 into x plus 2 squared plus, multiply 3 by that expression, this is what we're going to get. Multiply 3 by 1, we're going to get 3. You can write it in that form. That is what we call completing the square. Now, during the course of these segments, we're also going to deal with inequalities. I'm going to do some examples about inequalities. Now, with inequalities, instead of an equal sign, we use these values. We use these signs. All right. Let's say, for instance, if we're solving for x on this expression, if x squared is greater than 9. Now, what you're going to notice is that if you take 9 to the other side, you're going to have x squared minus 9 is less than 0. Minus 9 is less than 0. So if you take that expression as a function, what they're saying is that go and look for the y values or for the functional values which go for the and look for the functional values which are less than 0, That means we are looking for the y values whereby the graph is below y equals 0. So what we are looking for solutions. However, I made a mistake. I don't want to mislead anyone. There's a reason why I had to erase. All right, I'm erasing because on the solutions, I placed a dotted sign, a dotted solution point, and that's wrong because the sign there is not inclusive of the solution value at this point, because this is just less than, it is not less than or equals to. If it was less than or equals to, I was going to put a dotted solution. Now, this is how the graph will look like. Here, at x equals 0, okay, this is your x. At x equals 0, we have a minus 9. So now what they're saying is solve for x. Where is x when your graph is less than 0? This is the region. This is the area under the x-axis where y is equal to 0. So how do we express that section? So your x will be between these two values. Now, how do we solve these two values, the solutions? There's many ways. We can solve using the difference between two squares, or you can still use the formula that I gave to you, the quadratic formula. So if you use the difference between two squares, you will have x minus 3, x plus 3. Now x equals 3, or x equals minus 3 are solutions. No, are roots. But however, this is not the solution. The solution is, we just want to know what that value is. It means this value will be minus 3 and this one will be 3. So x is between minus 3 and 3. This is where it is. All right. Using the quadratic formula that I gave you, x will be minus b. Your b equals 0, minus 0 plus or minus the square root of b squared, which is 0 squared, minus 4ac. Your a is 1, and your c is minus 9. They are all over 2 times a, just 2 into 1. So this is your x equals, let's see, your x equals plus or minus 4 times 9. 2 times 9 is 18. 18 times 2 36 over 2. 36 divided by 2 no, sorry, it equals 36. Now the square root of 36 is 6. So x is given by equals 6 over 2 or minus 6 over 2. This is 3 or minus 3. So from here, we can go and use those solutions. And lastly, we have simultaneous equations. I'm not going to talk much about them. I'm going to do a lot of examples in the next segment. So, but the theory behind simultaneous equations is that whenever you have different functions, there will be an intersecting point. So when you solve simultaneous equations, you are solving for those intersecting points. I hope that helps a lot, and thank you guys for paying attention and watching the whole segment of exponents and surds. I will see you in the next segment. Thank you.